Hi, welcome back to the Motor Asha podcast. I've got Yogesh with me once again. We thought we'd have a interesting and almost a bring back memories kind of conversation this time with you, Yogesh. I was reading a few things this morning about how we used to work on old bikes and how technology has changed all of that today. So, welcome back, and let me start off with my first question to you. My first question is on older bikes, we were used to having a choke, and so the question to you is that what was that choke doing in the first place, and what has technology done today to replace that choke for the motorcycle?
Today also bikes use two means some use electronic, some use manual, mechanical, and chokes were used because at initial cold start engines they needed more fuel. So choke used to bypass the pilot circuit and is to provide more fuel so that the engine could get in the cold starting condition. More fuel was delivered to start it when the bikes are cold. Any engine, car engine, bike's engine, cold engine start needed a choke. Early times, chokes were what do you say? Means it was a part of every vehicle which was manufactured. Till in four wheelers, it started. The choke became electronic in the year 1987, I think so. From 1987, electronics chokes started coming. So once the engine is cold, it had a thermostat. So it used to have a supply from the coolant line, and it used to once the engine temperature reaches its operating temperature, the choke used to shut off. That was one. Another was a electromechanical choke, which used to pull the choke lever out. Once you start when the engine is cold, it used to pull the lever out and the engines used to start. In motorcycles, the electronic choke system came from 1997. All the bikes which came with the electronic choke model, and in 1997 bikes started coming with electronic choke model. Very few had a electromechanical choke model. But choke is that it delivers more fuel at cold start engines. That is what is choke. Later on, choke disappeared. Now all the bikes, not the commuting bikes, many commuting bikes today also have choke, which have carburetors, they have choke. So, but today's chokes and today's carburetor are way efficient than what it was that time. And now the fuel injection motorcycles don't have a choke system. They have a idle control system. So what that idle control system does is it controls the idle. When in a cold start, it increases the idle RPM and delivers more fuel. That delivery of more fuel is done via ECU. So that is how. Yes, when the engine operating temperature comes, that thing cuts off and the engine starts idling at its normal RPM. Whatever you have set, or the factory has say for 1000 RPM is the idle RPM. So when initially you start the bike, the idle RPM goes up by say 500, 700 RPM. Then as the temperature comes, it will drop down to its normal 1000 RPM range. So that is how these things work.
Okay, so is that the throttle position sensor also to play in this, or is it just an idle stepper motor that has come into technology that replaces the choke? Does the TPS do anything, and what does the TPS do Is there any relevance of it here?
Yes. TPS is throttle positioning sensor. Now, for example, if you in the cold start condition, if you open the throttle, say you uh, keep the throttle open little bit, 5 mm, 6 mm if you pull the throttle, or say 1-2 degrees if you pull the throttle and start the bike, the control unit will calculate the standard throttle opening which is not present, and so it will relevantly idle the engine to your throttle kept position, but it will again go to its normal setting if you leave the throttle. So if your bike, some bikes which have some maintenance issue, sometimes they will not start. This electronic ECU controlled idle control system, if they have some maintenance issue in them, they won't start. Cold start, they will not start. Then you have to, if you open the throttle 1-2 degrees, 3 degrees, if you hold it and press, it will start.
This is on a manual,
This
on
is
a
a manual
carburetor or
override. No,
okay,
fuel injection.
in a fuel injection.
Yeah.
Okay.
So this will happen only when there is some problem. Otherwise, it won't happen.
Got it.
You take any engine, single cylinder to multi-cylinder engine. If there is some problem, this issue will happen.
Okay.
So TPS is how much throttle you are opening. That is what the reading sent to that. TPS sends the reading to the ECU. That is what TPS does. Yeah, and TPS has many other parameters also. But for this related to choke, this
So the
This is
TPS
what-
doesn't play a big role.
TPS doesn't play too big role.
Too big a
in
role.
this.
Okay. Cool. Okay. My second question. I mean, I come from a generation where even I've sat down and adjusted points on an RD350 ignition. And I mean, half of the time I didn't even know what it was for. Somebody just told me that this is what you touch if you want to, get the ignition timing correct. So what was that? And today, what has it been replaced in modern fuel injection and digital fuel injection bikes?
Yeah, points. Points are gone. Points used to be a fantastic part of a motorcycle. But if I'll tell you now, if you see the design or the science or the craftsmanship which was involved in getting those points, means to adjust those points, there was a feeling. The person who could adjust those points to a actual 0-0 level and ride the motorcycle, it was a feeling that he is the best in the world.
Okay.
That feeling that points is to give. But points, now the points have been replaced by a Hall effect sensor. So you can say pickup coils. So points where these are two things. One, Hall effect sensor and pickup coils are two different things. Pickup coil is not used in fuel injection.
Okay.
Hall effect is used in fuel injection. So Hall effect sensor, there are two sensors. One is a camshaft positioning sensor. One is a crankshaft positioning sensor. So in some engines, some older engines, they have only crankshaft positioning sensor, so we'll talk about that only. Leave the camshaft sensor.
Okay, let's rewind back. What did the points do first?
Points. So points were adjusted on a certain degree to provide the optimal spark at a given timing. Okay. So it was like BTDC. So x and x degrees BTDC.
Got it. Yeah.
So for example, if we take like 10 degrees BTDC, so it is B before top dead center. So before top dead center, the spark has to
Yeah.
come.
So optimal combustion.
Optimal combustion.
Oh, got it.
So the fuel which is compressed, that spark has to come at the specific given degree where it will provide the smoothest and the most efficient output.
Got it.
So there you need to use something to produce that spark. So points were called as contact breaker points.
Got it.
So what was contact breaking? What contact it was breaking is, so it was used in correlation with a CDI, capacitor discharge ignition.
Got it. Yeah.
You called a CDI. So capacitor discharge ignition is that point was connected to the CDI. CDI's output was given to the HT coil, high tension coil. High tension coil's output was on the spark plug. So, see the calculation, how fast it is. When the points are closed, there is no spark.
Yeah.
Because when the points are closed, the capacitor in the CDI is charging. When the points open, the capacitor discharges. That discharge sends the voltage to the HT coil. That HT coil amplifies that 12 volts to 16,000, 18,000 volts, which goes to the spark plug. The spark plug, from the spark plug goes to the combustion chamber. So that is what the point used to do. It used to, it was set, it used to give, it was put there to break that contact to produce spark at a given degree. So there you use, their points were used. Now points also were used, they were gapped. Some points are very closed gap, say 1 mm. 1 mm, example it is, there were never points which was made for 1 mm. But that's an example. Say for some points are 1 mm, some 2, 3, 4. So that was the gap there. So the wider the gap, the stronger the ignition system was. Weaker the, smaller the gap, weaker the ignition system was. So that is how the points were made. I mean, that is why the points were used.
So what
Am
did
I
it get
clear?
replaced with now?
It was replaced in, first it was replaced with a pickup coil. Pickup coil, it had a striker. It was similar thing. It had a striker which was inside the magnet. So at a given degree, that pickup coil used to send a false signal to the ECU, not the ECU, the CDI. Then the cycle is same. Discharge, current, spark.
Yeah.
So it was replaced first with a pickup coil till carburetors. When fuel injection came in, this didn't work because it needed a precise
Timing.
striking point, precise. So it was replaced with a Hall effect sensor,
Got it.
which is now they call that also a pickup sensor. But we will call it as a crankshaft positioning sensor because points were mounted on the crankshaft. Pickup was mounted on the crankshaft, not on the crankshaft, but it was, crankshaft was the place from where it was taking the timing. So Hall effect was mounted outside the crankshaft above the magnet, and that magnet, the rotor, had points on that. At this given point, produce the spark.
Got it.
So then they started. Then now what has happened is, it has become so precise. Earlier there was only one striking point. For 2 cylinders, there were 2 striking points. Say for you take an RD and you put a RD into fuel injection. RD will have 2 striking points, 2 pickups, or 2 crankshaft sensors.
Yeah.
So one cylinder will get at that given degree. Cylinder 1 will get at that another given degree. Cylinder 2 will get this. So 2 came. You take a single cylinder RX100, it will have only 1 striking point, one sensor, crankshaft sensor. So points are replaced with a pickup coil, and then pickup coil was replaced with Hall effect sensors.
Okay. Nice, interesting. So I'll take you to the third thing that changed: spark plugs. I think at our time, spark plugs required a lot of gap adjustment. So what has changed now, and does it require that much of adjustments?
Today's spark plugs don't require much of adjustments unless they are of a very high quality spark plugs. For example, platinum, iridium. So earlier spark plugs you used a copper electrode. Copper electrode and a metal ground electrode. The spark used to come in between the copper electrode and the metal electrode. So as the time passes, that copper electrode which was producing the spark used to wear. It used to dissipate. So at given kilometers or given range, the factories have set the interval. At this X kilometers, open the spark plug, regap it, because the gaps will change. Gaps change, everything changes. Later on, that came with a copper alloy metal, which was a little better than the older version. Then again some metal came, then some addition of metals, then nickel, then all that thing started coming. Then finally today what we have are iridium spark plugs. They are top of the line. Iridium has a very high resistance, wear resistance. That is one. The spark produced with a iridium electrode is way better. Means precise, crisp spark is produced with an iridium. So for example, if all the ignition parameters are correct, the timing, the positioning and everything is correct, the production, the just remove a normal spark plug and put an iridium spark plug. Immediately you'll notice a difference. So that is what is iridium, and because it has a very low wear resistance, very high wear resistance, it is you don't need to regap it. It lasts long. Some manufacturers recommend, which are say for example adventure bikes, they recommend don't even bother to open the spark plug at every 10,000 interval, 5,000, 15, 20, whatever. Don't even bother to open it. Replace it at 60,000 kilometers. So that is what is the quality of spark plugs today. You don't have to do anything. And there are plugs which are made, these plugs which you don't have to open. They have a design and they have materials which are self-cleaning. There is no depositor on spark plugs.
Interesting. Okay, so I've got my last question, and I think this is a very highly debatable question on air-cooled engines and liquid-cooled engines. But the thing that I want to ask you is, what is the what happens to the engine oil, and what can go, what goes wrong in an engine oil in an air-cooled engine and a liquid-cooled engine, and what is better? Because we've been used to riding air-cooled engines before the advent of liquid-cooled engines. That's why I'm asking you that question, because at that time, how did bikes run with an air-cooled engine, and what could have gone wrong at that time with their engine oil? Mostly I want to focus on engine oil because I think that's the most damaged thing that happens over time between hot and cold. And what has changed now with liquid cool engines, and what does liquid cool engines do really to the engine oil or the engine in particular?
Air cooled engines, yes, definitely there was a issue with the oil. First thing is the time engines were developed was a air cooled engine, and that time oil was not engineered to that level. If you take a old 30-40 years back air cooled engine, you put today's oil in it, oil which is available today, the quality and grades of oil which are available today. Those times oil was a monograde oil,
Yeah.
40 number, 20 number, single digit oil. So there was no chemical engineering, means it was not of that capacity or quality of engineering which was going on that time in the engine oils. So I'll give you a comparison which will clarify this more. You take a 40-year-old motorcycle air cooled. You put the latest generation of oil. For example, that recommends a 40 number oil. So today you will not get a 40 number oil. You will get 20W40 or 10W40.
So multi-grade.
Multi-grade.
Yeah. Got it.
So our basic number is 40. This number doesn't matter.
Yeah.
This is all cold number. That is hot number. Higher. 40, 50, 60, 70 is a higher number. 10, 5, anything on the left side is for cold starting.
Yeah.
Those engines doesn't bother about that. They bothered about
The heat.
the heat.
Yeah.
So we will take a 20W40 basic engine oil, mineral, of today's. Top of the line basic mineral engine oil. So we will take a water cooled engine and we will take a air cooled engine 40 years back. Both are brand new engines. Example, both are brand new engines. You put the same oil in both the engines.
Okay.
You run both the vehicles.
Yeah.
At heat it. So what will air cooled initially? What will happen? The engine will start overheating. Because everything in that has a temperature limit, and after that it starts overheating. If you stuck in a traffic, there is no air coming.
Yeah.
How will it cool?
Got it.
It will not cool. Then what it will start? It will start eating that oil.
Okay.
Because oil will start losing the chemical properties. The additives which are there in the oil to sustain the detergents, the additives, then the molecule bonding of that oil, which is engineered today. Earlier it was not engineered. So that will start breaking off because that oil will start is reaching its flash point or the breaking point. Oil will start reaching its breaking point in the air cooled engine.
Yeah.
And here in a water cooled engine, the temperature is governed with a cooling system. So it will the radiator and all these fans and all that, it will keep the temperature to the given limit. Say the oil company says that when this oil will start depleting, losing its character, is at 200 degrees.
Yeah.
Now this water cooled engine is not crossing 105, 110 degrees. 120 degrees it will not cross. Yeah. Air cooled engine is already crossed 120. It's gone to 150 degrees. And that oil is started losing its chemical properties. So then wear, tear, breakage, everything will start happening. The fluidity and the viscosity gradient and the parameters, it will start losing. And now you are stuck for 1 hour. This water cooled engine is and oil capacity is optimum. Nothing has happened. But this has lost. And you get a free road to run.
Yeah.
You pull the throttle and you will start hearing noises.
Got it.
Because oil has lost its character. And that is the impact. It has taken that hammer. So it has lost its character.
Yeah.
Now you go, you rush, you get a gust of air, the engine cools down, the temperature comes to its normal operating temperature. You stop, then you stop, let both the bikes cool down. And if you think that it will be like now it's okay, no, it has already taken the impact. It has lost its character.
Yeah.
So, for example, in an air cooled engine, when the oil has taken hammerage, the wear and tear has started.
Yeah.
So, if this oil will was supposed to last for, according to that manufacturer of this oil, for 5,000 kilometers, it will last for only 2,000 to 2,500, half. But this water cooled engine will last for 5,000.
Yeah. So I think that's where the technology has changed, and now companies are able to tell you that, I mean, not in the sense of our conditions, but companies still tell you 16,000 and 15,000 kilometers.
That is bullshit.
Do you think so? Okay.
That is absolute bullshit.
Yeah, but in the conditions, I'm saying. So it depends on what kind of conditions you're riding in as well. Like if you're riding in an ideal condition where there's no traffic.
Now if you are in Himachal Pradesh,
no
you
traffic.
are in Kashmir,
where
the temperature never goes up.
Yeah,
I was talking about India.
And there's no traffic.
There is no traffic.
Yeah.
You are in, now these oil companies have that 16,000 kilometers. That is correct, but not in India. And so Pune city, forget it.
Yeah.
Pune, Mumbai, if you think, okay, company has said I will change the oil at 16,000 kilometers. Yes, you can.
Yeah.
But you have to rebuild the engine at 1 lakh kilometers.
Yes.
Better you change the oil at 5,000-7,000. Yeah. Put money in oil. And
good. So we'll keep that for a later stage of what is the, what are some of the things that you think that the companies tell and you think, no, that should not happen. So we'll keep that for another conversation. That was actually a very interesting conversation, more than interesting, some knowledge for me. And I actually went through a few articles myself to read about these topics. And I mean, like I said, from where to where we have come, it's interesting. And I think it just makes our bikes run longer. And more than that, they behave the same as they were a few years back. So but thanks so much for your knowledge. There's a few things that, even like I said, there was a few things that I read and I couldn't understand myself. But like you said, to recap, the choke got replaced by an idle stepper motor. The spark plugs have got replaced now. The crank position sensor has been replaced by the point system, and the air cooled and the liquid cooled. So good technologies. But thanks so much for your knowledge, Yogesh. Always
most
good
welcome
to pass by and get all this gyan from you. Thanks for listening to this podcast. I want to hear your stories, your motorcycle experiences, what you've been doing, and how motorcycles have made your life better. So if you have something to say, DM us on Instagram, and I'll be more than happy to get you on this podcast.